Are you ready? I'm Ed Nersessian, director of the center. Before I introduce the participants of today's roundtable, I have two brief announcements. One is that the next program on the beauty and unity of mathematics is on December 1. And then on December 15, it's a program on animal consciousness. And then other programs you will see if you go to the website. I will make a very brief introduction of the participants today. If you want more information on them, you go to our website. There's a detailed bio there. Michael First, who is sitting right there, is professor of clinical psychiatry at Columbia University. Laura Hirschbein is professor of psychiatry at University of Michigan. Francis Lee is the chair of the Department of Psychiatry at Cornell Medicine. Robert Michaels is the Walsh McDermott University Professor of Medicine and Psychiatry at Weill Cornell. And Miklos Tott is the neuroscientist, professor of pharmacology at Weill Cornell. So as you know, the format is a spontaneous conversation amongst the participants. Thank you. Thank you. Okay. Who wants to get it going?
Well, we were just talking a minute ago before everybody started about the fact that I'm a historian and I'm the only woman and the only non-New Yorker, so I guess I have a perspective. But we were talking about wondering whether the history should start first if we're looking to the future. But the problem with starting in the past is if you're imagining a narrative, do we want the way people tend to use history is to tell the story about the present. Are we talking about the past as the battle days that are leading to the future with new discoveries, new advances, new neuroscience, new whatever, or are we going to use the past to tell a story of decline, that we've lost track of the things that we used to do well, and now we're in soulless territory of just symptom counting with due appreciation to DSM. So you can use the history to tell the story of decline, the story of progress, or, as I tend to see it, the story of things that continue, the themes that come up over and over and over and over and over again. The things that we discover and rediscover. We discover brains, we discover symptoms, we discover statistics. I'm reading a great book on the history of statistics now that points out that we psychiatrists were doing statistical counting in the 17th century. And so the idea of counting and looking at numbers is not new.
We humans like to do that. It's the first step of trying to understand things is to put some you need louder?
They're louder.
Put some order in things. And hopefully patterns will emerge and we'll have understanding. So that's been going on for a very long time, and that continues to be, it used to be the main, everybody wonders in the DSM, Diagnostic and Statistical Manual, what was the statistical part? And that was because it originally was used for collecting statistics in mental hospitals. And nowadays, I guess you could argue the coding allows people to collect statistics, but it's really the only reason they keep the S is for historical reasons. It's a well-known document, but it's really not statistical anymore. But you're right, it's the idea of starting out the DSM unfortunately remains a descriptive observational system with almost no depth to it at all. And people have criticized it for that reason, which is certainly a valid criticism, but it remains useful because there's no alternative. That's always the thing. When somebody trashes the DSM, it's, well, okay, so what do you want to replace it with? And usually you don't get much response. So it's incredibly limited, but it continues, despite all of the advances in neuroscience and everything else, it continues to have value as an organizing principle. But it's still very limited.
I think the historical perspective actually is very useful. I remember 15 years ago, I think, when all the genes came out. I'm looking everything from the basic science point of view. I have to just a disclaimer. But I remember that one of the attractions of this field is that these new genes came out, and everybody believed that after a while we will be able to explain some of the symptoms, and maybe actually we can define a certain disease based on disease genes. And historically now we know that it's actually absolutely not the case. If anything, it's even more complicated. Mm-hmm. So I've been struggling with this in my own lab and in the university, that how actually to solve that problem. And we can discuss it later, but obviously we have to move out from the single gene and even multiple gene, because we have to understand how the environment is really impinging on this whole gene network, and we will have time maybe discuss about that. I think still the genome is a culprit, and the genome can, or epigenome rather, can explain a lot of things. So historically, I think we really moved a lot from genes, and now we have the epigenome. And hopefully we'll have some chance to get a little bit deeper into this, how, because that's still, we are in a very same situation. We have an epigenome now, but like in the 80s, 90s, that we have a lot of things, but we don't understand how they work together, how they interact. Mm-hmm. But I think it's a little bit more better situation now. We have more players. So it's almost like we need another level of understanding.
I think we do know more. I'm also a neuroscientist, and I was just at a symposium at Cornell and yesterday, and from lots of different neuroscientists
There's
across
something
the country.
wrong with the sound, Miguel.
And what was absolutely clear was...
It's muffled here, too.
Is this better? Is that we are not actually much closer to understanding the pathophysiology of psychiatric disorders, despite the hundreds of genes that have now been found. The best example, I was at this meeting, was that the success story now, the best success story in psychiatry is autism. 99 genes will now have met genome-wide significance, or very penetrant, high effect sizes. They account for 1% or less than 1% of all autism in this population. But each of these papers is a Nature paper. So this is considered the best advance that we can do at this point. And it's absolutely not clear how to move forward. And I think this is something that I struggle with also. It suggests that that the hope, as Miklos said, was that 20 years ago or 30 years ago was just like in pulmonology or nephrology, we would just get a bunch of genes and then be able to, or cancer, and then be able to move forward. And what's clear is that this is not a linear path, that the brain is probably more complicated. There's some number like 150,000 or 150 trillion synapses. This is just for us to be able to think that a single gene or 100 genes could help explaining it. This is going to be difficult. So it was a very sobering meeting I went to.
But if I may just reflect that, so basically I think the situation is like 15 years ago in the when Facebook was or Amazon started. Yeah. So basically the idea, if you think about it, is that you get all of this information, they collect information, personal information, and 15 years ago they just started. Yeah. Now they have a tremendous amount of information. And now, from each of us. Now they have algorithms that they can actually figure out what your next move is, and maybe send you an advertisement, and we want to sell you some pet food or something because you know that you have a pet at home. So and more complex. So I was thinking maybe that kind of strategy, because we have now genes, epigenomes, and a lot of that loci, right? Yeah. We have thousands of this. Yeah. So how to put together all of individual players as they would pull out the society to a comprehensive understanding of how the society works and how the brain works. But I was just thinking the other day about this, but it's still probably it's not the right template, because it's a very two-dimensional what they do. They just collect and they can interpret. What our problem is that we have multidimensional. We have genes, then we have synapses, connectivity, then we have circuit functions, and then we have this behavior, which is very elusive, right? But most people work with at that level. So I think it has to be something where you could integrate these data sets, like you had the Facebook interface, but sets, but you would be able to actually, in a 3D almost fashion, to integrate all of this information to a comprehensive understanding of the brain. I have no idea what basically I'm talking about here, but I'm just basically I'm saying that it's just something which will be the next. Most of the time in research you don't really know what is the next big step, but it's something has to be way beyond of this two-dimensional understanding what we have now, and probably nobody knows this. It's just somebody will come up. So that's why I think it's a good idea to invest. NIH and IMH puts a lot of money in these things. There are computation people now, artificial intelligence comes in. So maybe something is coming out, but we don't know what it is. And unfortunately, we will not be able to answer the future of psychiatry, I'm afraid. But we just have to put money and then waiting for the internet as a concept to coming out from this. And I don't see it yet.
I'm not for the major conditions, let's say bipolar disorder or schizophrenia, for example. Are the studies focused on finding out what causes the condition, or are the studies also focused on dissecting it into the symptoms and trying to figure out what causes each symptom?
I think at this point, the main, at least from what I can get, the main thrust where the money is going is collecting as many samples as possible to get hundreds of thousands of samples of biological samples from mainly DNA and other, and to try to do large statistical analysis of essentially genome-wide association studies. And they've succeeded in finding now over 200 schizophrenia genes, accounting again for low percentages of the risk, like 0.5% of the risks for schizophrenia. They just completed in England a study where they took 100,000 people with depression, and they were able to find 50 genes that looked like they might be affected.
15?
50. But again, low effect sizes for each of these. But it's essentially, this is where the efforts are to. Again, it's this is sort of like counting. It's sort of like they just want to accumulate as many potential genes that might be a risk gene at this point. And these are still early days, I would say. Yeah. But 20 years ago, there were none. So if you divide by 0, this is infinitely better.
Well, if you say 50 genes are responsible for the depression, then what?
But they account for so little of the risk. So it's sort of like it's a small effect size. So that there is the best, as an example is, one of the genes is a glutamate receptor, which makes somewhat sense. Glutamate receptors are everywhere now. But the problem with this one glutamate receptor they found is that it's everywhere. So how you're going to actually target a drug, or something like that is going to be very difficult. Drug companies have been targeting this class of receptors already, so in many ways we've known this. Then we're sort of stuck with again the complexity of the nervous system and the brain, and that even though we have one hit that makes some sense, it's still very hard to move forward. Yeah.
It's interesting thinking about all of this data because, again, this brings me back to this book I'm reading on the history of statistics and psychiatry in particular, where they were drowning in data in the 19th century. One of Emile Kraepelin's arguments was that he was spending all of his time with data. He had so much data, he didn't know what to do with it. And obviously, we have a better capacity for managing data, but the thing that came after all of this data gathering in the early 20th century was Freud and psychoanalysis that said, okay, we're not going to talk about these big groups. We're going to talk about one person, and we're going to talk about what makes up this one person and how this one person's inner conflicts manifested in these symptoms or these experiences. And so I'm wondering if the future maybe if somebody gets to the point where we have all this data and it's little pixels and it's everywhere and it doesn't cohere to a particular picture, that we're going to have another wave of people saying, no, actually what we need are individual relationships. You know, we're spending all of our time bumping into people as we're looking on our phones, not engaging with people. Are we going to have a backlash where and maybe psychiatrists will lead, maybe will follow, to say, no, actually what we need to do is work on interpersonal interactions and that one patient again, and go back in a different way. I don't know.
Have we stopped doing that now?
According to some of our patients, we have.
But I think it's really, they are not exclusive. And
Absolutely.
You have to just do both. We do certainly the large data, but in the clinics you do certainly the individual. But our goal is really to understand the basic framework of a disease rather than an individual. And maybe how an individual can end up with a disease phenotype from this overall concept. And you are more interested in obviously why this person got that. But I think it's just the two sides of the same story, and we just have to do both.
There's an interesting sort of like similar backlash going right now in this other field of systems neuroscience, where people thought that we just need to neuroimage more people, and as they're going through various tasks, or even where they're sitting, just to look at their brain connectome. Just to bring everyone up to speed, 20 years ago, it was found that the brain actually organizes itself into sort of like hubs in the brain, and you can actually just get what they call a resting state without any task. You can actually get a scan and actually see these hubs in the brain. And this is the work of Marcus Raichl at Washington University. And people were fascinated by this, and no one has really been able to sort of understand how is it that you can measure blood flow in the brain and actually see these self-organized networks. And so then everyone got excited and just kept on collecting thousands and thousands of scans. So now we have hundreds of thousands of scans within studies. Now at WashU, where Marcus is there, they now decided that everyone's network is individualized. Everyone's brain is, that when you average it, you get a brain that looks like no brain on the planet Earth. So now what they're doing is that they're actually taking individuals and actually just scanning them over and over again. For example, during the course of depression or during something, so they can scan them at the height of symptom pathology, and then at some other point when they're not. So I think this is the goal now, that you might want to basically go back to and then learn something from these individuals in a way that had not been thought of before.
I think there have been some drug studies on that this N of 1 studies, where you take a single person as the study,
exactly,
and how they interact with medication, and that's sort of this new thing that's being. Yeah.
Because there's so many individual differences. It's essentially that you can't, the principles that even of trying to put together a brain connectome is very difficult, even though NIH is spending lots of money on these connectome projects, that ultimately it might actually just sort of like if you want to understand fruit, you don't blend it together.
But I believe that response is a little bit simpler, because when you ask the question why this drug is actually working in one individual, actually we understand the pharmacology of that based on an enzyme which is either stronger or weaker in certain individuals. We call it CYP enzymes. But basically they just metabolize the drug. Many times this is crucial. So, and we can, even now, a patient can be screened because it's genetically based. One can take a sample from blood, and every cell is the same, and we can basically figure out whether it's a fast metabolizer or a slow metabolizer. And maybe that's the reason somebody is actually has side effects, or another person does not respond, and it's just a dose relationship. So that may be somewhat easier to understand than what the underlying cause, which could be thousands of different ways. But I still believe that there's still something common feature or features, whether it's a circuitry. I kind of start to believe in circuitry now, nowadays, but maybe it's just because it's fashionable. But circuitry in animal models, at least we can understand how the circuitry can be linked to a certain behavior. We can modulate the circuitry, we can activate, we can deactivate certain very precise circuitry. Even we can tailor, we call it synaptic transmission in certain areas of the brain, and we get the response. But of course, below and underneath, there's a lot of genes and synapses and other things we just don't really understand.
I'm going to go back to where we started and be a little provocative. To me, psychiatry is defined, like all medical specialties, as everything that's relevant to helping people with a certain kind of problem. And the neuroscience research base that we've been talking about is fascinating, exciting, intriguing, and essentially totally irrelevant to helping any living patient. It may have some hope for the future, although a possible outcome of the work is that this strategy won't lead to anything helpful for patients, or maybe to some modest twists on some of our current drugs. Almost all of our current biologic treatments were discovered by happenstance, not by scientific research. They're serendipitous. If we never spent a penny on any neuroscience basic research over the last 100 years, it would make trivial difference to current psychiatric patients.
But we didn't know that. I mean, obviously,
No, clearly it
that's
was-
the problem. I mean,
it
the
was
thought
worth it.
was that we were going to crack the problem by going neuroscience. It
But
didn't
as
work
our
out that way.
historian warned us, we have to study the past
Yeah, right.
to find out that we won't repeat it.
So it wasn't money, it was wasted in the sense it didn't give us what we wanted, but
I'm
we
not saying it
needed to
was
spend it
wasted,
to see it.
but
yeah.
it led to nothing.
Yes, right.
Yeah, it was a very intelligent gamble that lost.
So,
Short-term lost. We don't know about the future. I just want that for background, because when we talk about the excitement of contemporary neuroscience research, we're talking about possible hopes for a fairly distant future. We're not talking about anyone who's mentally ill today or anything that might help that person.
But one of the side effects of the neuroscience thing is, I believe it's been partly responsible for lowering the stigma of mental disorders. And it's unfortunate because somehow, if it's in the brain, therefore people shouldn't be stigma. I mean, the fact that it has helped stigma in a way is sad that it took something like this, but I think it has. People having a brain disease, calling schizophrenia a brain disease, I mean, all over, and calling substance abuse a brain, if you believe it's a brain disease, but people call it a brain disease partly to try to reduce the stigma. So this angle, besides the fact that we're trying to look for answers, is actually, I think, had an improvement with respect to the place of psychiatry in medicine, and also the place of patients with mental disorders within the midst of medical
But
patients.
that's the rhetoric of neuroscience,
Yes,
not
exactly.
the findings.
No, but that's a positive benefit. All this money was if it achieved nothing but that, then it would have been well spent, I think is what I'm
But
saying.
the downside of that, though, is that the patient's expectations of what we can do for them are
that's true.
sky high. You know, that they sit there and wait for us to fix their brain disease while they don't want to put any effort
I have too
into-
much serotonin. I read about that. I want you to
Right.
give me a drug to reduce that, and then I'll feel better. And
Right. And so the expectations are very high. Our drugs are okay. Our therapies are good, but people have to put
Yeah.
effort into it, right?
But I think this happened really outside of neuroscience. For example, if it's infectious diseases, going back hundreds of years, and then people figured out that if it's a cleaner environment, probably they can avoid something. We didn't know microbiome or microorganisms. But I think eventually when these bugs were discovered, cloned, the gene structure understood, then we know the target. We can design antibiotics more precisely, not just by luck. Like not penicillin was certainly luck, but now everything is designed. Or AIDS would have not been treated the way unless, we had the virus, we had the structure, we have the genome, and actually the drugs which are developed are targeting a particular gene. So I think we are just a few hundred years maybe behind in psychiatry, but basically history tells me that, yes, this is the typical curve. There are accidental and fortuitous findings, and we use it because that's the only way we have. Maybe they are not even useful to develop further drugs, like in a serotonin blockers, and so that we couldn't go further beyond that. So we need some other information to build another way. And we are just not there yet, but I think we have to just be patient, and I don't know if we'll be see that in time, but it just have to be, this is the normal course, I think, research and medicine.
I would, first of all, as I always say, I agree with you, Bob. Is that, and I think it's sort of reflected by the fact that the Cornell residents, psychiatry residents, really have to know nothing about the brain in order to be an outstanding resident. That the training itself does not require us to even know the mechanism of action of any of the drugs that they're given, because we actually don't know, for example, even how lithium...
We try to teach them during medical school, which is not taken very seriously.
But what would you say the way forward is if instead of putting our X% GDP into neuroscience research, how would you construct moving the field of psychiatry, which, as you said, is to help these people that are living very difficult lives, and a large proportion of them, for example, are in prison. And how do we help these as psychiatrists or psychologists?
An impossibly difficult but very important question. And I'll translate it pragmatically. How should the nation devote its resources toward the issues of mental illness? And we're doing it wrong. We're spending too much money in tertiary care for people with serious mental illnesses, not enough money in preventive medicine, even where we know certain things that would make a difference and would work. We certainly would do much more for the next X years, 50, 100, of the population's psychiatric problems if we put more money into early child development, mentoring experiences at a facility than in tertiary care strategies for the persistent and chronic mentally ill that are biologic in nature. We know that the pattern of drug use in this country has more to do with physicians needing to placate dissatisfied and angry patients rather than with knowledge about the impact of the drugs on their behavior or their brain. But we know that the skillful physicians know they can reduce the patient's dissatisfaction with the treatment by writing a prescription. And the more expensive the medicine, the better the effect. And the pharmaceutical industry has figured that out also. And we go along with it. But it's very hard to revise the system so the goal is total public health rather than satisfying individual consumers. And our current health delivery system has as its output satisfying consumers rather than the health of the nation. That's a public health disaster which is supported politically. That's not really psychiatry, but it has a lot more to do with mental health in the next 100 years than neuroscience does.
The only thing I would say, though, is we've already put an X number of billions or millions, hundreds of millions of dollars in these sort of early intervention studies, public health efforts such as Head Start. And I've not yet seen any data is it just that we have not put enough? Or is it because it's not clear to me that we're moving the needle even with the programs we have now? Or is it that the needle is just so hard to move?
Well, I'm not sure Head Start's the answer, Francis, but for example, you know the study, I'm sure better than I do, that the children of depressed mothers who are depressed during pregnancy and in their postpartum period have bad mental health outcomes. We know how to treat depression better than most things we know how to treat, including depressed pregnant women and depressed women postpartum. But we don't deliver that treatment effectively to lots of populations. We would have more public health, mental health benefit by organizing a more effective intervention to assure the mental health of pregnant and postpartum women than almost anything else we get for $1 in mental health. I think the neuroscience is fascinating. I believe we should invest in it. But I think that there's an image problem. I think we sell it with the implication that it's going to make a difference soon. And I don't think that's true. On the other hand, if we tell the truth, we're going to lose resources. So people act rationally. The way you get the largest grant and the greatest congressional appropriation is to suggest not that the connectomes are fascinating, but they may lead to a cure for Alzheimer's disease, possibly Thursday. And you can't imagine anyone not using that strategy, because we do have data that strategy works.
Well, the trade-off there is that there's a fixed amount of money available for research, and we've seen in NIH the amount of research that's gone into treatment development. It's all got shunted over into this neuroscience thing. So, I mean, if we had unlimited money, then we go, I can do some neuroscience and we can do this, but it doesn't work that way. So part of somebody's getting the money, or certain portions of psychiatry and neuroscience are getting the money, but the patients, I think the treatment research is really dried up. A lot of it is going to depending on pharmaceutical companies, and they have, unfortunately, their motives aren't always aligned with ours. So it's a real problem. But you're right. This is the way you sell money from the government. But unfortunately, by diluting the government into these promises, we don't get good results for the research, and we're really depriving the use of the money elsewhere. Again, I don't know what the solution is, but I think that's a problem with the success of getting money for neuroscience.
Well, isn't the hope that the research is going to give you the tools?
Oh, no, that's right. But I think, as Bob was implying, that's not happening.
The fact that it's not happening, I mean, Bob said it's not happening soon, but what does that mean? It's not happening tomorrow, it's not happening in 20 years, it's not happening in 50 years? Or maybe never is the problem. The one thing that's been very clear, as everybody said, the more we study it, the more difficult it gets. And that's years ago, this neuroscience thing, all we had to do is sequence the genome, all we have to do is this, all we have to do is that. And every time we do that, we're just waiting for that one. There's not a single biological test in psychiatry for diagnosis. And one thing I remember when I was working with Alan Francis on the DSM-4, we wrote this guidebook. And we put a sentence in the guidebook. It was in the Alzheimer's section. And we were saying that we're very confident in the next 5 years, by the time this book is out, there's going to be a biological test for Alzheimer's. And boy, was that all. It's still off. 25 years later, and we're still... You speak to the Alzheimer's people, they say, another 5 years to get that right. But there's this elusiveness to actually turning these into... Now, it's not clear what you do about that. You don't want to say, well, let's just give up and stop doing it. But there is this problem with putting money in a direction that has proven to be very, very complicated. At what point... Again, if we had a limit on money, I'd say, well, let's keep pursuing that, but it's coming at the cost of resources being spent on research for better delivery of treatment. You just mentioned the thing about the delivery of the treatment. We do know how to treat depression in pregnant women, but there's a delivery problem. I mean, putting all our money into figuring out how to solve those problems would probably get better short-term results. But those are much harder to sell. Let's spend money on delivery of care. When I was in medical school in a pathology lab, one of the professors would walk around the lab while we were looking at microscopes of cancer cells, cancer tissue, while he was smoking. And so we, as medical students, told him, you are a professor of pathology, we are looking at cancer, there's a connection between lung cancer and smoking, why are you smoking? He said, cancer is cured in 10 years. I'm talking about the 60s. Uh-huh. So, but that doesn't mean that the research in cancer has not borne a lot of fruit, so that today with immune therapy, targeted therapy, and so on, we are so much further than when I was a medical student. So why wouldn't the same thing happen?
Well, and you're right. The parallels there, of course, right? That it's going to be cured in 10 years thing happens all over medicine. They've actually made a lot more progress. Like the precision medicine is a good example. That entire field and all of, when you apply that to psychiatry, we are so far away. Whenever precision medicine is discussed, it's always cancer. I mean, has been the area of medicine with, I guess you could argue, infectious disease has always been precision medicine, but cancer is a great example. And they have made, I mean, you could argue that all that amount of money spent on cancer, which has been, by the way, historically much, much more, orders of magnitude more than was spent in mental health. But you're right, that's finally beginning to pay off. And part of it, I think, however complicated the cancer story is, it is more tractable than I think the psychiatry story because of all of the, it's just so much more complex, the brain, then I think that we always assume the cancer thing would be that hard because it looks like it should be simple, and that's turned out to be extremely complex. So there's a parallel there. It looks doable, and then we see it's not, and you put a lot of money in it, and finally we're getting some results. So that would be the argument. Let's just do it in our field, and the same thing will happen, and it's possible. But I think the only downside of that is there's a limited pie of money, and what's not being spent on by pursuing this goal.
But just as follow up with what Miklos says and what you're saying, it probably means that we will probably have to spend as much money as we do in cancer, which is probably 10 times as much as being spent on all brain disorders. So it's not surprising we've not moved the needle at this point,
That's
given
true.
the fact, and that it took cancer. Maybe a better analogy is to think that we're about 30 years behind cancer. That might be the best way to think about it at this point. And that in order to get to where cancer is, we're going to have to put more money in. And I would, not to be as provocative as Bob, but I would actually say that the money that was spent on sort of fundamental neuroscience or fundamental biology is probably the best money spent because we really don't know the brain that well. We think we do. If you think about why we move so quickly in terms of tackling HIV to a sort of a chronic disease, it's because of the fundamental biology of understanding how viruses replicate.
And so just basically emphasizing that neuroscience is not necessarily just linked to psychiatry, but we have to talk about neurology and many, many other
drug abuse.
So basically this money, first of all, is not a big amount from the basic science perspective, to be honest. Compared to the cancer, it's like peanuts. But basically, so this money is really not only understanding disease, but also understanding how the brain functions, which has different implications in computer science or societal problems or behavioral things, which has nothing to do with an exact disease necessarily, but still how we interact with each other, social behavior, wars and peace, and a lot of implications. Yeah. So I think, in fact, a relatively small portion of the so-called basic neuroscience budget is spent on directly disease-related, and it's not a lot of money, unfortunately, and there's a lot of competition for this money. That's, I totally understand that it's not enough. Other field, but I think it's not whether you put left or right the money. It just has to be conceptually different thinking at the governmental level or the city level. So it's just a thinking, but what we not enough money going there. I totally agree, but it's not the problem of the social, the basic science budget because it has to fight for a reason.
I pretty much agree with what's been said, but I would add something and suggest a possible inference. One is I'm a strong advocate of basic research. Neuroscience is basic research, like molecular biology or genetics. The yield on that is greater than any other research we do. But it has woefully little to do with psychiatry. That's all. I'm not arguing it's not interesting, not relevant, not helpful, not practical. It just isn't particularly related to psychiatry. Its major relationship to psychiatry is the rhetoric of social funding. You can't get somebody who's in control of a foundation to give you $100 million for connectome study, but you can for Alzheimer's study. And therefore it requires someone who knows how to write the paragraph that starts with the statistics about Alzheimer's and ends with So, I think I just did something there.
Yes, I think you have to move on to it.
And ends with something about connectomes. The other thing is that there's a sort of public image which makes perfect sense, that we have these huge problems. We have heart disease, we have cancer, we have mental illness and neurologic diseases. But it doesn't work that way from a biology point of view. The brain is more complicated than the rest of the body put together. The brain diseases are more challenging in terms of their understanding and treatment than all the other diseases we ever think of or treat. That they're, help me, we have basic scientists in the room, so I want help. About 40% of all the genes go to the brain? How much is it?
Expressed?
Huh?
Probably 60.
60%.
Yeah.
Well, that's a measure of something or other.
But how they express?
Pardon?
But how they express, that's the question.
Of course, but
That's the main
just
question.
the magnitude is relevant in that we're dealing with what the maker thought was half of his problem. And we know that anyone who ever went to medical school knows that you can slice all the other organs, and then most biomedical research, when I was involved in laboratory work, started by slicing an organ and putting it in a Waring blender. But you can't do that with the brain. Doesn't work that way. So the fact that the brain is more than everything else in terms of the complexity of its problem is an important proviso. So certainly we need more basic research. Psychiatry deals with very difficult problems, and I think Francis is optimistic when he says 30 years, that we're about 30 years behind. You said that, didn't you?
Yes.
Francis and I met 30 years ago. That may be where he got the number. I think we have to recognize that there's an order of magnitude difference in the problems we face when we talk about the future of cardiology or oncology or orthopedics or ophthalmology on the one hand, and the future of psychiatry on the other. But one of the startling things we're going to face in the future of psychiatry is that most of the people we'll be treating 50 years from now, we don't think of as being patients now, because we haven't conceptualized how we can make a difference in their lives. But the history of the last 50 years in psychiatry is we moved from Ed's two major diseases, schizophrenia and bipolar disease, to recognize the huge pools of people out there who have personality disorders, who have addictions, who have problems in living that were never thought of as medical or psychiatric, but can be helped by interventions even at the crude level we're at now. I don't think we're going to see that growth of patients with cancer or heart disease or any other disease category, but we are with mental health diseases.
But if I can just go back to this cancer example, I remember, because Memorial Sloan Kettering is just next door, and we have a lot of collaborations. So they were stuck with cancer like 20, 25 years ago. They have been developing new drugs which are a little bit different than the previous one. They certainly got a little increase, but it's not a tremendous movement. And then suddenly there was a paradigm shift with this immune therapy which was mentioned. And nobody knew that it's coming. It just came out from the dark, and then obviously people have been working on it. Yeah. But suddenly there was a critical mass or critical finding, a mass of critical findings, which were translatable to humans. In mouse, one could do that well before, but it had to be developed a technology where you could actually use it in humans, and humans will tolerate this. And I think in cancer research will tell you that that was a paradigm shift. Because now it's not only personal, but the cure rate is incredible. It's very expensive, but I think it's just, you never know when it happens. It can happen in next year, and it can happen in 50 years. So, but I'm just waiting for such a paradigm shift, which we don't really know, as they didn't know that this will pan out, because they are trying different things, from bone marrow transplantation to different things. But this, for some reason, became practical, feasible in humans, and actually this is
But was it because of I don't know it so well, but is it because there was some basic leap made in immunology that made this happen?
I'm not familiar.
Yeah.
I'm just hearing from them that it was just suddenly a change. Labs would switch to this kind of strategy. They're far better. And now you have these people who have been not responders. They suddenly, and they were on that road. Basically, they were no chance. They just come back. I mean, it's a miracle.
Yeah.
So this is what we would need in psychiatry, that somebody would be treatment-resistant schizophrenics, which is really serious, or suicidal. And then suddenly you have a treatment which we just cannot even comprehend that today.
Maybe we should all study
but why
immunology.
We don't believe that. Sorry?
We should all study immunology at this point.
Or return to studying.
There are important constraints. For example, the reason why they made part of the reason why they made the progress on immunology and so on is the ability to study cancer cells. It's not that easy to study schizophrenia cells. So cancer allowed you to study things in a completely different way from different angles, and even now the treatment comes in from different.
Well, the lack of an animal model for schizophrenia. I mean, animal models for cancer have always been around. I mean,
Exactly.
It's a huge barrier. I mean,
So the
theoretically, if
problem
there
is
was
that
could be a breakthrough. If some really amazing animal model for some of these illnesses came up, that could open the door for a lot.
I would say, though, that I think it might have been basic understanding of immunology, because that actually also, now we have drugs for MS, multiple sclerosis, that we didn't have. And they're also in the immunotherapy realm also, where they target the T cells. So it turns out even neurologists just got lucky that it turns out that these advances, that the drugs that they were making to basically make T cells quiescent, are actually very effective for MS, and they didn't. So I think this will, and it's still a chronic disorder, but they had nothing a decade ago. You know, the fact that they have 3 to 4 new drugs in the pipeline is still quite impressive. So I think we are waiting for that moment also.
So in terms of research, where is the research in psychiatry in terms of those major illnesses I mentioned?
Yeah.
Where is that research focused on?
I think that
genetics, or
I would say most of the money right now is in genetics, connectome. These are the brain initiative is essentially neuroimaging, and then it's continuing.
A lot of money goes to epigenetic, which is
epigenetic.
But epigenetics, I think, just to mention for the audiences, that basically once people realize that genes will not solve the problem, and we know that environment cannot work through genes, so the concept came in that environment will actually produce some change in the DNA structure or the DNA function without changing a base pair. So the sequence is the same, but there are secondary modifications. But if you view it from a functional perspective, it doesn't really matter whether you have a mutation and it alters a gene function, or you have we call chromatin, which is the larger assemble of the DNA and the surrounding proteins. You can have a same functional change as a result of. So many people I know, because it's pretty competitive, nobody's to write a grant, but basically the common theme is that you propose that environment, whether this is early childhood adversity, whether maybe it's during pregnancy, maybe the mother is depressed, but there is something, memory built into the child or a fetal DNA, which is again not a change of the sequence, but it's a permanent. So the child will born with this. It's a regulatory problem, like a mutation would be. And it ending up with a little bit different function at the gene level, which is translated to a circuitry level, and then functional level when the child is an adolescent, typically, when this connection is made. So I think that a lot of money goes into this, which is fundamentally a very good concept and very new, because we don't really know this. We call this areas as environmental sensitive areas, maybe, or we can call them marks or whatever you want to call, but we don't really understand those.
But even outside of neuroscience, epigenetics is also
cancer.
Cancer.
It's actually cancer is a more developed phase again. Yeah. So we learn a lot from cancers. Yeah. But some of the cancer findings cannot be translated because the genes which are regulated are totally different. In cancer, you would have that how fast these cells proliferate or divide, grow, and in neuroscience, more important, how maybe a synaptic function is really tailored. So it's a little bit different. And it's, again, it's just several order of magnitude more complex. That's the problem, the complexity what you pointed out, which means that it takes more time.
But just to sort of simplify your work, Miklos, but what you've found in your own lab is that the level of stress of the mother, the grandmother, or the great-grandfather, or whatever, all have impacts on the infant. Right?
So we can trace down on the granddaughters. I'm talking about animals here, but there are some human studies, but the granddaughters will carry the memory of a grandparent. Either you can have like stress, infection, or even early childhood adversity, which would be very relevant to psychiatry. So we can actually tell from the granddaughter DNA that the grandmother had some impact. So that would be very useful to, let's say you have a child and you are not sure whether the child will be more, you see some sign, maybe I'm not a clinician, but I can imagine that you have a child and you are not really sure whether the risk is very high or no, but you see some signs, you could go back and then test whether that child actually had some kind of impact through some ancestor's life. And you would say, yes, I see some impact, so I would be more careful and maybe treat that particular individual.
And you can actually sample the epigenome not by having to get a brain biopsy, but by...
Yeah, we are doing from the blood, actually. So we don't have to kill the mouse. so we just take a little blood and we can... Because the blood also responds to this, and there is a correlation between the blood response to the brain response. These are not, so I'm talking of memory. The memory in this case, you cannot say this is how precise like an episode would be in our life, or a room, or remembering this environment. It's really just the adversity component. It's a negative balance of this whole situation, which is really somehow alters certain genes, which will be...
So it's like a genetic fingerprint.
So it's not a memory. We like to use memory because everybody understands memory, but it's a loose memory. So you will not, just an example, you will not remember that the adversity occurred in A or B or C environment, but you know there was some really bad experience. It's not post-traumatic stress disorder where somebody can recall the exact location and going back to the same restaurant or the same battlefield, it will have a reaction. It is more of a general anxiety that in general, the anxiety level is really high. Almost sometimes you don't even know why, because the person doesn't have to have an input. It's already built in the DNA, the chromatin or epigenome, which was somehow predated, maybe not even in the individual's life, but in the ancestor's life.
So your mechanism is beautiful and articulate and very sophisticated, but that basic understanding that a person is affected by their ancestry, psychiatrists have been saying for 150 years. So that's not new.
No. Nothing is new in science.
Right. So
but
the
how
thing
it works.
Well, but the thing that worries me, of course, is that exact thinking is what got us to eugenics. This idea that the best thing to do would be just eliminate those genes, eliminate those people, eliminate those races, with the obvious conclusions in what happened in Germany. And so, and the thing is that the scary part of those kinds of interventions is they start off well-intended and in the United States. So it wasn't just, these crazy folks in another country. And so again, the question is, all right, so you found this, then what?
But just responding, so what you would say that is known, it was totally anecdotal. There was no scientific evidence for that. And in science, we never believe, so at least in basic science, we never take it really true until you actually prove mechanistically. So our standards are really mechanistically.
But for the standards of the time, but they looked at pedigrees, they gathered data, they interviewed families. For the standards of the time, they knew exactly the same thing.
Yeah. But yes, so there was certainly such an association, we call it association. And now, from a scientific point of view, you want to have the association to a causative relationship, because if this is association, you cannot do anything about it. Because if two things can be associated and you influence one thing, it doesn't feel act on another thing. So
But my point is, though, for the standards of for the scientific standards of the time, 150 years ago, that was truth.
Absolutely.
That was the truth. It wasn't. I mean, they believed that was causal.
Yeah.
Now you're saying this is truth, and so I wouldn't doubt that your science is more sophisticated. The question is, 150 years from now, is somebody going to look back and say, well, you know, your science was all very nice, but.
Could be.
So, I mean, that's the kind of...
But a big difference is when you have a causative relationship, then you have a chance to actually manipulate the system. If an association, then basically the two things are independent from each other, it's just coincidental. So you don't have the opportunity or the chance to actually influence your outcome with something which is correlated with. So that's a big difference.
Because they thought they did. I mean, they thought they did.
Yeah, but it's wrong. There are wrong things in science.
We don't know that. Our crude treatments, because they're crude, you know, would match the sensitivity of that kind of science.
I'm more precise. With this treatment, even in SSRI, that's not really causative. We don't call it causative because it's an association. So causative when you have an absolute known player molecule pathway which is linked to, and then you manipulate that pathway, and then you fix the outcome. So that's what we need for develop new drugs.
Are there any conditions where it has been shown specific epigenetic change is responsible for it?
So this is another problem. So there's not one single gene or a single locus, but and then we don't have a manipulation where it's multiple. So that's very difficult to make the, but I think that's actually one way to think about it, to figure out a way to work with multiple genes. But I remember when I was at school, manipulating one gene was a tall order. Nowadays, grad student will start in the lab, and in 1 month, the person can change that gene, one single gene. We can manipulate with 3 genes, and if you ask yeast people, yeast would be just a single cell and a lot of the same cell. They can manipulate thousands at the same time. What we would need is that to manipulate hundreds of genes or thousands of genes in a complex mammalian neuron. And we just don't have the technology, but people have been working.
But in cancer, aren't they using various HDAC inhibitors right now?
Yes.
To try to affect the epigenome?
Yes, but they are not, because selectivity, that's also not enough.
They don't have it yet.
Yeah, selectivity is really important, that you basically target only those, nothing else.
Exactly.
And there's the classical manipulation, what we had 20 years ago developed, we don't have in multiple genes, a lot of genes, because that's all multi-genes. So, but not only the psychiatric conditions, but cardiovascular, diabetes, hypertension, these are all the same problem, and they cannot really prove because they have tens of hundreds of genes. One person has this combination, another person has that combination, but we do know that it's probably a lot of genes, each has a very small contribution, but you still need, they have different constellations. So these are all systems biology. So I think system biology is another field which might need a lot of money. But again, much higher level than artificial intelligence would do nowadays, which is one-dimensional sale.
I want to use this to segue to something that I think is often not seen this way, but the availability of our finer tools for assessing genetic risk at the level even of an ovum means that we're really into a form of euthanasia, except very early. So when we decide to not implant a fertilized egg that's carrying the Huntington's gene, that's just early euthanasia. Early eugenics, I'm sorry. Early eugenics. Biologically, it's the same thing. We're clearing the population of a noxious gene by selecting who will support and who will destroy. The Nazis waited a few decades afterwards before doing the same thing. And we don't really have a dialogue socially about the meaning of that and our attitude toward it. We're doing something in a way, even more intriguing because the methods for doing this are available to some social classes and not to others. So we've set up a system where if you're in a certain social class, you get eugenics to get rid of bad genes, and if you're in a different class, you don't. And we're going to distribute the bad genes class-wise in the culture. That's a very interesting psychiatric, I don't know if it's a psychiatric issue, maybe. I think much of what our effective interventions might be in the next few decades may be at the pre-implantation level of eugenics. We can possibly get rid of some major psychiatric disorders if we have enough community acceptance of screening and selective implantation of fertilized ovum that don't carry those disorders.
The thing that is, I mean, apart from the larger ethical issues, of which there are many, the other thing that strikes me is if we're trying to help, say, schizophrenia, if we're focusing on schizophrenia, if we're trying to convince our patients who have schizophrenia that they have lives worth living, that disease is not going to define them, that they can live full lives, that they have worth as a human. And then at the same time, we say that we're going to try to eliminate the genetic risk for that. You know, what does that say? You know, we care about you, but actually we wish you hadn't been born. I mean, and that, you know, we're not at a stage where we really have to wrestle with that other than as a thought experiment. But that's...
We're close to it.
Well, depending on who you talk to, you know.
So just totally agree. And yesterday I just accidentally opened NIH, National Institute for Health. But there's a whole branch trying to really address this question. So it's very relevant. But I recall another effort from NIH, which is more of a repairing the gene or genes. So there are a lot of money goes into our field, which is basically say, this is a situation, and it's a child is born, but can be really re-establish the normal regulation or whatever situation. And now, just a couple of years, people, you know, the new technology where you can actually get in the cell. Again, it's just a cell level. We don't have the brain level. But now some can do it, and a single gene, and you can actually repair it. You can eliminate the physical or molecular problem, and basically it's very similar to repairing an enzyme defect, for example, with a virus where you would have a child with an enzyme defect. And it's pretty, technically speaking, it's relatively simple because it's just an enzyme which is everywhere. So you make a white blood cell, and this white blood cell be produced now, and you exchange the deficient cells with the gene therapy. So that's a similar concept, except that you go to the brain cell or brain region, and then you basically reestablish the normal situation. It's science fiction, and it's just laboratory things, but it's certainly in the lab. It's in one gene it can be done. And it's just 5 years ago that was the first, or 4 years ago. So there are new things happening.
Yeah.
And we just need a larger, not only new things, but we need a scale up from one, it's always with one gene, and then we have to have 100 genes simultaneously. So it's going a little slow, obviously. But,
well, some degree of the repair of genes, the technology is there now.
It's not only a mutation you can repair. You can this so-called epigenetic, what I referred, which is more complex. You can repair that as well.
But the issue is, in terms of mental illness, is to first determine what genes we are talking about.
Sure. If you have 100 genes of small effect, you can't be fixing those genes. That's not going to make any difference.
But the whole idea in science is that you have these hundreds of tracks of research, and some people are working on this, and suddenly everything will just converge, and that's the hope. So they scale up the technology, the brain. We don't have access to the brain, so we need new technology to get to the brain. So when everything converges, maybe 100 years from now, then this is where you say, maybe it was worth to invest this money, but otherwise we wouldn't be there. And that's the hope. But I think that was a hope in cancer.
The thing is, though, that we do need to help our patients now, and, you know, it isn't sexy, but there is a lot in systems of care that we in psychiatry used to do a lot with. The whole asylum movement, the whole beginning of the profession of psychiatry in the United States was based on systems of care, this idea that we build asylums to take care of people, to restore them to sanity. And so we have similar problems to what Dorothea Dix was complaining about 170 years ago. We have people in the jails, people on the streets, people who are suffering, who don't have family looking after them. And in Michigan, we are reinventing the idea that we need to take a look at state hospitals. Our Republican governors over succeeding decades closed most of our state hospitals, and now all of a sudden we have to have a conversation about maybe reopening new kinds of new systems of care and working on ways of taking care of people because gene therapy isn't available in our lifetime. Sure. It's hard to talk about that. It's hard to say, yeah, we need bricks and mortar. We don't just need
But
genes.
I think it's two different things, so we have to talk about both.
Yeah.
I mean, I'm not saying that, the money should come from there. I mean, this is more a political issue, actually, what you're saying.
But for the patient for the next 20 years, neuroscience is probably not going to touch them.
It's
right?
probably not the solution.
That's the problem.
It's like, probably all the astrophysics is not necessarily in our lifetime, but we still pay or fund astrophysics or going to the moon, or probably we won't be there in the next few years, but still, in some respect, that's how humanity and technologies develops.
But just to segue into something that might be a little bit more positive. So even though I think that neuroscience is going to take 20 years, there are certain things that, and it just happens by sheer coincidence, it's happening in my department, but at Cornell, we have figured, one of the investigators at Cornell, who's a psychiatrist, has figured out a way to use neuroimaging to subtype depression into 4 categories by the connectome. And he is able to do it, granted it's only one study of 1,200 patients, but he's able to basically get to do it with 90% specificity and sensitivity. So he has the shot of actually possibly getting the first biomarker for a psychiatric disorder.
What subtypes? Where did the subtypes come from?
So what he did was he got 600 patients with major depression, and 4 other age-matched controls, got their resting state scans, which I described there, and basically through machine learning / artificial intelligence, asked the computer to tell them, do these people fall into different subtypes? Do the brain connectomes look different from the controls? And then the computer gave what they call a classifier, sort of like, yes, here's a template where this is the template for depression number 1, 2, 3, 4. Then he took another set of samples of 300 new people with depression or not depression or schizophrenia, and this classifier could separate out people with schizophrenia versus depression with 99% precision. And so
these are different subtypes, and DSM doesn't have.
No, they're not phenomenological subtypes.
No, these were. The computer was not taught DSM, so the computer was agnostic to what it was just looking at essentially. And each subtype has a slightly different abnormality in connectivity with the prefrontal cortex. So first of all, he confirmed that the prefrontal cortex is probably very important for major depression, and they all have slightly different.
But they don't look different clinically, is the point, right?
I guess that was.
They really don't look that different clinically.
Miraculously, subtypes actually fall into anhedonic, anxious. They actually fit.
They do, really.
They amazingly do, and it was not taught. The computer was not taught this, and so
that's nice.
Yeah, so that essentially they naturally, which makes sense that if you're anhedonic, then the hub that's involved in the reward circuitry is probably going to be the one that's broken, while the one where you're sort of more anxious is going to be probably more prefrontal cortical because of the anxiety circuits related there. So it fell out naturally. And now we're going to, but what is so remarkable is that, so there's another form of treatment called transmagnetic stimulation, which was which we had wild enthusiasm 10 years ago, but has shown to be only effective for 40% and for mild to moderate depression. What he found was that only one subtype responded optimally to TMS. So now the new clinical trial he's running is to do that was a retrospective study that he did. Now he's doing a prospective study to see whether or not he can subtype them ahead of time, then give them TMS and basically see whether or not that this is actually going to hold up. But you can sort of now see how you can use this. Not obviously we as psychiatrists and psychologists and social workers, we can diagnose pretty well, but what this can tell you is that what he noticed was that after the people who responded to TMS, their connect tone changed to normal. So basically, you now have not only a diagnostic tool, but something that could probably tell you whether or not the treatments you've had were possibly effective or not effective in changing at least one sort of at least some objective measure and stuff. So that the future would be, at least only at Cornell, but maybe other places, that you would get your brain scanned in the outpatient clinic if you come in for depression, and then basically then different treatments would be tailored to that. It sounds very, but
You mean one brain scan will tell you this?
yes. So because he got the computer to come up with what they call a computational classifier. So then the classifier will then sort of sort it out and just say this you fit into biotype 1, 2, 3, or 4, and so then and if you put in someone who has schizophrenia, they go, you don't fit into any of these biotypes. You are not depressed. So he's now trying to develop the schizophrenia biotype and the bipolar disorder biotype. But for now, he started with depression. So, but the reason why this was possible was because so many people in the country and were doing resting state scans. So he didn't have to scan 1,200 people. He got people's data from 1,200 people, from 1,200 subjects, and then just use the computer to basically do the analysis. But I think this is probably what's going to happen, and that's why it's still important to do all these studies, because who knew that this 10-minute resting state scan was going to be so important for this type of work? I think, and so the idea is that we would basically be able to tailor things, but it is really quite remarkable. Even to me, it's hard to wrap my mind around the fact that the brain has an intrinsic connectivity that can be picked up in 10 minutes by an MRI machine, essentially, that's been around for 50 years. So essentially, technology was always there. What he did is he was just like, he just put the pieces together, and was able to do this. Yeah.
Let's hope it replicates. Psychiatry is full of 50 years of starting the DST of tests that look like they're going to be great.
So
and it
the
falls
two
apart.
replications are now being written up. So the replications for the biotyping. So people from other universities, not us.
Really? Excellent.
So for depression, not for any other disorder.
Well, depression, that'd be pretty damn good if you had that.
We'll see what happens. But what's really nice is that, the thing that I got from it was then we've also begun, or he has begun doing anxiety disorders, because that's the other disorder. And the people with anxiety disorders fall into that. But again, us office, DSM, the brain did not read DSM. Eventually, going to be these going to disorders, and not the sort of are probably going to be very different for each. So, I can assure you that I hope it replicates too.
But that's an optimistic note, so we can stop the open for questions. If you have a question, you walk to the...
A few years ago, half the facts, and looked at various fields of science over the years and how many years it took for half the things people thought were true to be no longer true. So I'm wondering for each of you, how many years will it take for half of what you think is true now to be not true.
Yeah, I'm not going to predict the future, but I will tell you a funny story about I found a book that was written from the American College of Pharmacology. And in, I think, in 1965, they wrote this book called Psychopharmacology in the Year 2000, where they were predicting it's going to, and they were drugs that would keep people happy, helping them happy and help them that weren't happy, because we weren't going to solve the food problems, but LSD was the answer to everything. It was going to cure alcoholism. It was going to cure schizophrenia. It was everything. And then 2 years after this book was in the United States, it didn't take long. Right. Well, what I was going to say, we're back to hallucinogens. Now we're looking at ketamine.
Had they not banned it, maybe over the 30 years we'd actually have drugs on it. That was a big mistake. What's going to be true or not true? Yeah, like that, that's the way paper that you can laugh at when it's that's pretty funny. And the other, you had and he was writing a paper about the RDoC project. So RDoC project was an attempt to toss out the DSM approach to phenomenology and based. Yeah. The idea is we're going to discover the circuits of the brain, and then we're going to build up, this huge, all these studies. We're going to explore treatments. Went out on a limb and said, in 15 years, will happen. It was so off. Yeah. And the thing to me is the fool of predicting something in 15 years, because those are all can't ever. So you're right. I mean, assume a lot of what we know is going to be.
Thank you, Dr. Lee. At the end, you mentioned models to differentiate a rested brain from atypical brains.
So these are in patients.
Patients.
Yes.
And it just made me wonder, what is a healthy brain?
The brain we have.
That's
So someone that doesn't meet any criteria for any DSM disorder, but you're absolutely right.
Are there people who don't?
It's sort of a circular argument. But so I think we don't have a really good idea of what brain is. It's just what we call brain. So a brain, these things codified as a subject.
We have an idea of what the healthy mind is, though, don't we? The analysts have figured that out.
Thank you for this. And my question is, with some questions about which way funding should go, what will be what's the patients and patient goals, and what values should guide values should guide medicine and administration? What's the future of PCORI grants? Those questions.
So,
You'll do better.
So PCORI grants are supposed to be, so there's been whatever various new things. Then when we to the community, that seem to work really center, but they're too complicated or something to be implemented. And so it's supposed to be something where you take a treatment and grant is to actually disseminate. For example, I think the types of grants have a great early cognitive behavioral therapy that has been validated institution can use to the Queens Clinic and have trained the people there and then rally around it. Lots of money is being poured into these human trials. How are treatments typical? I would have to say that the bigger question is that we actually don't, just to sort of segue, we actually don't have the workforce to deliver much of the treatment. 20% of our population have that workforce. So I'm not actually sure. I would say that no. I think what the rationale for the grants has been mainly due to the treatment. More sophisticated behavioral treatments have been able to be implemented, but it's probably because they don't have enough providers that can deliver it in some way. I think.
To pick up two threads of Dr. Mike. One of them about prevention and the allocation. About being, I'm going to echo that also. Given how we started off with the progress with the genetic research, given that, we spent most of the time talking about that at this meeting. So what does that mean? So I will offer an interpretation, considering where we are today, and that there's an enormous cultural, almost delusional denial of the source of most pathology, which Dr. Michaels mentioned, which has something to do with early development, early attachment, traumatic abandonment, early childhood. Even we know data from moving to another country, and mental illness, and yet there's no money being provided for that kind of research. So I suggest we take all of the money and then we make as far as so now I wasn't being provocative. Just the second is the irrelevance of the neuroscience research. I think you mentioned expectation and amongst patients. To get better, that's rampant in psychiatry, and I think, and that's all part of the getting rid of stigma. I don't think we're getting rid of stigma. Okay, as if they were broken brains. We've just added another kind. A person than he did at case conferences. Okay, the conferences had less details about actress or even that there's a strong who order pharmacogenetic testing and getting a history.
Several comments are called for. I'll start with the last one. I think the psychological, psychodynamic community is strongly in favor of talking to patients, listening to them, and getting to know them in fine texture and detail, which you feel a member of, I suspect, from what you said. I think that community has failed to demonstrate value added from the information it collects for the majority of psychiatric patients. So although we may not like it, the fact is that if you want to be cost effective, the first thing you do is make a DSM, then use the standard treatment for that diagnosis, and wait 8 weeks. A third of your patients will be better. And there's no point in finding out how they felt about their mother. It's irrelevant to the outcome of the intervention. If your focus is on the outcome of the intervention, you'd focus your subtle, nuanced history-taking and relationship development on the group of patients who need it and might profit from it. But the community doesn't like doing that. And it has an almost ethical quality. It's not humanistic. No orthopedic surgeon worries about being humanistic before setting a Colles fracture. But psychiatrists do sometimes. Or, conversely, they don't because they're tired of those that do, and they're arguing with them. So your DSM diagnoses begin to, in many psychiatrists' hands, substitute who the person is sitting next to you on the bus. It's an unsolved problem. It's a major problem in psychiatric education. So that if you travel around the country and you make rounds and things like that, you find a fair number of young psychiatrists are very happy if they can document a DSM-5 diagnostic conclusion, even if they don't have the vaguest idea who it is they're talking about. On the other hand, the research problem not resolved is when does it make a difference? And very importantly, when does it not make a difference?
Even more provocative, I think the lack of engagement impairs the reaching of a proper diagnosis. I'm not talking about
Sometimes.
people being in analysis. I'm talking about even doing a proper workup.
Sometimes.
Well, often enough.
I would agree with it. I think too often. I think you can't do a. I mean, obviously, I created a structured interview for research, and I see people do horrible jobs because they don't ask the right, get below the surface. I mean, it's not a checklist, and nobody who's ever worked on the DSM has ever claimed otherwise. However, because it looks so simple, there's a human nature here to do the simple, quick thing. And the DSM, you could argue, is one of the worst things that happen because it's allowed psychiatrists to do what our colleagues in the rest of medicine do, which is try to do the quicker thing, like getting a bunch of lab tests and not talking to the patient. So it's facilitated that. It's had a plus. I think it's treatment and people have responded better, but there's a huge cost. And I agree about the psychiatric education. It's up to psychiatric education to go against that tendency for people to want a cookbook approach and tell them over and over again you're not going to get good results. Now, unfortunately, it would be nice if there were studies that could actually show for sure that check actually in outcomes. It's hard for me to believe you're right. It would be somebody could do some kind of. You got people who. My guess would be out the better.
Why do you done?
Who's going to fund that? You're right. It'd be a great thing to do.
But there's also an ideology in the profession. You're a patient in depth, that it's almost a virtue rather than efficiency or efficacy.
Right.
And that's a weak argument in a competitive world.
No, you're right. You can see how we've gotten where we are, and
Exactly.
it'd be great if we can undo that with data.
Yeah, if you had like the head of some federal finance, health finance and said, well, we need to do this, then they would ask, well, just show me why we should invest billions in this direction rather than in this direction.
We need that study, a series of it.
But we may be going backwards and having to do that retrospectively with the current generation of kids we're raising now. So we're raising an entire generation of consumers of mental health care who think that all they have to do is sit there and somebody will do it. They will do a checklist, they'll get a diagnosis, they'll get a pill. Then they role in that. It's something that they, again, it's our failure to treat rather than their failure to engage. So I just had a patient in the hospital, a 19-year-old student, and we get a lot of university students at U of M on the inpatient unit, and she'd had depression. I don't know what that means for this teenager, but she'd been on every drug I could name. She'd gotten ECT. She had never engaged with therapy because, as far as she was concerned, that was effort that she didn't want to put into. And we were done. She was still depressed. She was not bothering to go to her. And, you know, she needed to actually put some work in, and she didn't want to hear that. She wanted the magic pill. We're, you know, raising a generation of consumers of mental health care to not take a role in their own recovery, and I worry about that.
I'm pleased that we've reached a position. We still have. And that brought at the beginning the sociological. My question, that statement, have any of you been studying abilities? Now there's anxiety. Anxiety may be identified as a good state if it's, you know, guided correctly. The person is facing something in society that is not right. Again.
Is a symptom, not necessarily, it's a state. It's not bad. I mean, we all know, you know, if you have a test due and you don't have enough anxiety to study for it, you're going to fail it. Anxiety are adaptive parts of being human being.
You can't live without
Exactly. Perhaps even or adaptivity. Deal with illness using it in that context, but when you have these symptoms coupled with some disability that's causing, it somehow impacts your ability to function, what you need to ships, work, you know, these symptoms being severe enough. It's always been in normal grieving for 1 year after the loss of loved one every day and agree right with that person. So there's always a point where you figure out when these symptoms are here, when, you know, it's when they become exaggerated. By case basis, it can be very easy to do. But in principle, that's the theory.
Let's
My name is Vin. I am interested I have a suggestion to make, and I would like to have a response to it. David, wrote about The Man Who Couldn't Stop. Obsessive compulsive disorder. Okay? My question, my statement here is that in the review of the book that I have, Adam argues he is in favor of a more complex suggests from a categorical approach to mental illness, which the categorical approach driven by the DSM. Thank you.
That was the when DSM was the preparation, the approach, the whole one of the I don't know how it was to move it. Anyone in the field knows that the categorical approach is a fiction. There's no hard boundary between any mild depression, life. So medicine, the rest of medicine is categorical and dementia. Measure people's you have a category. So this tension between measuring and recognizing that there has to be a point where you go from a measurement to a category. The DSM has been people reify. They think these boundaries in the book handed down from or something, not the high. and somehow they have some meaning to really shouldn't have. So I've always, as a lifelong, thing with it. So we're struggling with what happens to the cats and how they become real. Clinicians to practice because you wouldn't know the time to give medicine. Right now, if you have 5 out of 9 symptoms of depression, and all the clinical trials which use that definition, you could say, well, if my patient version of depression, the one that was in the trial, I don't know, their probability of responding to this treatment is because that's what the study shows. About not enough for an illness. Boundaries are that you have to. That's why it says at the front of the book, go into training and see a lot of patients to be able to get the feel for what they are. But is they opened the door up to continuous revisions. They realized that it was arbitrary to 6 years we're going to redo the whole book. Now they said that, one of the reasons they did that is very difficult to roll. In the electronic world, the belief is but now there's actually a committee set up, and anyone from the world outside can make proposals. Now, if you make a proposal, you have to have the data to back it up, but there's a democratic process.
The other thing with the system, it's great in theory and very critical of DSM, have had issues with and this does somebody have it or not criteria, but the dimensions are incredibly sort of in a lot of want to put a controlled on, or you don't, but systems that were created by psychiatrists who have their own professional stake in all, so complicated that I can't imagine anybody actually using these factor analyses with 20 different domains, and if you're high in this and low, it's like it's only on
MPI.
Yeah. So incredibly complex. So it's not any more real. It's not. It's one set of problems.
Thank you.
Issue, which is disease. DSM serves. In general, dimensional approaches preserve information. Categorical approaches discard information. When you reduce multiple dimensions into they're willing to spend a lot of time. Clinicians to throw out data. They have. So that my guess, 20 diagnoses DSM, certainly not much. And there's an argument. DSM is efficient for every purpose. It says that in the first sentence of the introduction. But the authors of DSM are largely not. They're largely investigators. Primary loyalty. Personality disorders, lots of data, but the dimensions are most complex. So the committee that was supposed to solve the problem came up with a dimensional system. Then the parent committee worried about it, and extra committees were brought in to review it and decide about it. And we ended up with both, you lose it. If somebody with a treatment that was correlated with the dimensions would suddenly become very, very popular.
Yeah, I agree with that.
Thank you.
Thank you very much for participating in this. It's been very good to hear everybody's opinions. I just, when you guys were referring to the issue that is the separation that occurred at the turn of the century with Freud versus Jasper, don't really, in the proper way. I think that there was a group of people that were mainly psychiatrists dealing with a population which was, history individuals, whereas Jaspers and the German philosophical psychiatrists were looking at people who were much more profoundly dysfunctional. They were in and had different depths of illness. Jaspers, in his treatise, did not the meat, and the biological psychiatrists have to see some type of biological basis for, whereas the outpatient psychiatrists predominantly were what is that dispute continued for a century, and in complete it's pretty clear that the first predominated psychiatrists until psychology was introduced. Then it was no biological markers were found. A silent outpatient. The biggest as if they are, you know, like discipline. These are diseases, event, and that's been one of the leading misunderstandings, because what's happened is that, you know, 100 genes about the brain is a psychiatry from a lot of the other new disciplines that deal with the brain, which is much more linear. And I mean, of course, they've expanded, because at one point they were freaking out because they could find the lesion, and they thought they were all going to be part of, which was initially meant for community, subsequently became that represents a hierarchical level organization that has its own code. So answers, that becomes misleading. It's too linear for the majority of psychiatric disorders that are based on genetics. Usually, the reason why there hasn't been more literature that has been able to prove is because, of course, linear mechanisms are much, much easier to. So now we start to understand that those people make the world is what is making them feel when they take.
Can you close it? Can you come to a closure? Because I have people waiting. We have to stop.
But the bottom line. That's why you can't prove order. Those are the most important things that make life worth living. Those are the things that are of the mind. And even Claude, the information theorist, when he said, you know, was the father of information, it's not really about information that he proved. It was just statistics of data,
okay,
but
thanks.
not of meaning.
Thank you. I think you made your point.
Hi. As a data person myself, I wanted to offer up the results from a literature review out of the University of Colorado Denver's School of Medicine. They looked at meta-analysis of all the published studies up until 2012 on antidepressant use versus the use of psychodynamic psychotherapy. And what they found was that the effect size in there were 74 studies on the use of antidepressants alone was 0.3, which means about 3 standard deviations between the control group and the intervention group that received antidepressants. And when they looked at studies in where they had control groups versus patients that had received psychodynamic psychotherapy, the average effect. Understanding, it seems that there's something about establishing a alliance, a relation focused on expressing feelings. When those things are established in the treatment patient, and idea and see.
Cancer or myocardial infarction or tuberculosis.
Or dentistry.
Or dentistry, right, we'd be horrified. So that's important. There are different treatments. There are several types of psychotherapy. Cognitive behavior therapy is very popular. Dynamic therapy is the beloved of dynamically oriented psychiatrists. Pharmacotherapy. All treatments seem to have order of magnitude similar effect to mild to moderate depression. My own reading is that with severe depression, the pharmacotherapy shows an advantage, but even more striking, you don't even mention it, the most effective treatment for severe depression is electroconvulsive therapy. There's a huge amount of data on that. It's not even in your survey. But again, more important, getting adequate treatment. Image of depression is you're well, depressed, recover, or you may need treatment, and then you get better, and then you're well again. That's not the natural history of depression. The majority of depressed patients have a long-term, usually lifelong, predisposition or vulnerability to depression, and they have more than one episode. And therefore, an important goal of the treatment is to modify that vulnerability and the likelihood of subsequent episodes. We've been dramatically effective in that with bipolar disease, but that's a small amount of total depression. It's not quite clear how effective we are long-term. Is that if you continue the treatment indefinitely, it continues to work. But no patient continues treatment indefinitely. Pathologic transfer to their therapist. So we have a problem. You want me to end?
No, go ahead.
We have a problem.
I thought you were
about that.
finished.
Bottom line, though, is that the drugs are effective. Take the drugs first. In fact, the best drugs we have help about 1/3 of the patients who take them. That's not widely recognized, partly because the pharmaceutical industry doesn't advertise it that way. They'll tell you 2/3 of the patients who take the drugs get better, which is true. But with a placebo, 1/3 ecologic efficacy, our best pharmacologic treatments, affects 1/3 of the people who take the treatment. The same might be true of our psychotherapy in terms of treating depression. From the look on your face, you don't like that idea.
I've read multiple studies on the use of psychopharmacology versus psychotherapy versus the combined. And as my understanding, I have not seen any literature that shows that psychopharmacology alone has better outcomes than the combination of the two. So I mean, we could argue maybe that implications forever. We can do that offline, but that's my understanding. I have not seen anything that any empirical evidence has.
Thank you. No, it's the other gentleman, I think, first.
I'll be quick. I'm interested to know what the panelists think about the future hope for psychiatric treatment by hallucinogenics, specifically psilocybin and ketamine. Interested to know what the state of the situation is now and what the prognosis is for future research and application.
It's still pretty early. I think that studies are now, so certainly the ketamine story, because ketamine is legal to give and easier to study. As with most things, it's got a little hype in the beginning, but as more studies are being done, there's clearly solid evidence that people respond to ketamine, and people who are treatment-resistant depression and don't respond to anything else sometimes respond to ketamine. The problem with ketamine, of course, is it requires continuous treatment.
And we don't know how often we can
Yeah,
give
there's a lot we don't know. There's a signal there that has been now established.
Someone who takes it will be better for one week, but that's about as far as we know.
As far as the rest of the psychedelics go, again, there's a signal there as well. I mean, this is the sad thing is because of what happened in the 60s and the overreaction to the misuse of psychedelics, these things have been out of the hands of researchers for 40, 50 years. Now, luckily, it's coming back in, and the studies are now coming in more and more, the clinical trials for all kinds of, originally it was with cancer patients who were terminal, because, there's only people who could be given the meds that were allowed, and they got very good results. And it's now they're trying for more and more applications, and the future of psychedelic treatment is looking very promising. But the problem is we don't want to start telling people they should go buy mushrooms on the street and start taking it, because there's so much that's unknown, dosing, and these things have bad effects. Even the studies that use psilocybin, there's certain. It's complicated.
Like, what is the placebo?
That's a problem, because you're right. People know. I think I have something that has effects. So at least they.
I think we'll stop after this.
Hi, thank you. So there were two contrasts that were brought up. One was between medicine and psychiatry, somatic medicine doctors and psychiatrists, and the other contrast was this between. The book was from my generation. The way we got to know patients is by know patients. But it seems to me that there's kind of been an irony that in the course of my career as a psychiatrist, where I've watched medicine people very, very interested in narrative. So now at Columbia, you can get a master's degree in narrative medicine, and the medical courses. That's psychiatry. We abdicated great skills in a sense, and it's funny to me that we're not the ones teaching narrative medicine to the next generation of medical students.
Almost universal myth that's untrue and is interesting. Freud, of course, was not a psychiatrist. Freud was a neurologist who treated patients who ended up, we know the rest of the story. But the psychiatry grows out of general medicine. Neurology wasn't a specialty. Freud was seeing his patient, outpatient, with physical symptoms. The history analysis led to its moving away from medicine and away from psychiatry. But in fact, in my view, analytic interview skills and patient recognition are most with non colitis. The patient who are supposed to learn or used to be supposed to learn these things, although the inpatient seriously mentally ill population illnesses, schizoid disease, are probably least and people. They're much more important. Physically ill or mentally ill. But this works again.
Stuff on an inpatient patient, you depth, hospital, but the hospital, he's not taking his meds anymore after him. So there's a the story. And it's funny, at University of Michigan, we've reinvented a medical humanities program, quarters of the, because we say, yeah, this is our stuff, we need to name it.
Okay.
I'm a fourth-year medical student applying for psychiatry, so very interested in this talk, and I really thank you all for being here today. So my question, when I envision the future and understanding all the neuroscience we're talking about, immunology and more targeted therapies, nanobots, hallucinogens, all the neurostimulation, but for what I'm hearing from this is the future of psychiatry. It sounds more like reallocating resources, delivering care. Is my future as a psychiatrist, are we going to see more of the acceleration of kind of the fancy new therapies and modalities, or should we really be advocating for spending the money where it's going to be most impactful, things like housing or the early child interventions?
I'll take a shot at this. So in 5 years after you finish your residency, you will only see the most ill patients. And then at some point, so that most of the other mild to moderate will hopefully be taken care of by primary care or some other. You will at some point realize that the treatments that your armamentarium you have is limited. Then you will go, I heard this talk about psilocybin. I got to do something for my patient. This is why I think there's such great interest, because we have a limited repertoire of what we can offer our very, very ill patients. And we have